Okay, so here we go with our first question. Another question here. Actually, this question is the solution to the first question which I gave right in my class. And if you look at it, you have to show that TK equal to theta C plus 273. Already you know that TK is temperature in Kelvin. TK equals temperature in Kelvin, right? And we know that theta C equal to the temperature in Celsius. So what we have to show here is to show that temperature in Kelvin equal to temperature in degrees Celsius plus 273. So with this scale of preference, we're going to have to carry out a conversion here. We know that this point here, the upper point here, is the upper fixed point for Kelvin. So I'm going to be calling this Kelvin, and I'm going to be calling this one Celsius scale. So for Kelvin scale, we know that the upper fixed point, which is the boiling point, is always 373. It's always 373 Kelvin, and the lower fixed point is always 273 Kelvin. And for the Celsius scale, we know that the upper fixed point is 100 degrees Celsius and the lower fixed point is 0 degrees Celsius. So since I am converting theta C to theta K, I'm going to be calling here, let's call the value there. So we give the value there, let us give it X. I'll be X Kelvin, right? X Kelvin, which we don't know what that will be, or we can likewise, since we are converting this to theta K, let's go down here and call the value here, right? Let's call the value here X degrees Celsius. So I'm going to be say X degrees Celsius is equivalent to my theta C. Okay, so if that's the case, then we are looking for the same value on this scale, which is equivalent to we can say YK. Now from here, YK is equal to theta K. So we can do this right directly by using the fundamental interval idea. So the fundamental interval idea is to say YK minus 273. So you have Y. In this case now, you have Y minus 273, right? So that will be basically divided by 373 minus 273. 373 minus 273. And that will be equal to, on the other hand there, it's going to be equal to X minus 0. And that will be divided by, of course, 100 minus 0. And of course, at this side, at the range of this side, what we're going to be getting off this is Y minus 273 divided by 373 minus 273 is going to give you 100, and that will be equal to, on this side, X minus 0, and that's definitely going to be X over 100 minus 0, which is going to be 100, right? We can move it so quickly to this side. Right, so we can go to this side. So here we are going to be taking some cross multiplication, right? And this is going to give us, of course, that will give us 100 into the bracket of, right, Y minus 273 and minus 273, right? And that will be equal to the 100 to be multiplied by the X, right? And if that be the case, I do not need to take this division out because this 100 cancelled out that 100. So I'm guessing we are having y minus 273 equal to the other part, which is x, right? And from here I will have to fix in the values that I was, that I need before. This yk, of course, that was yk, that is yk, so that is yk, right? So I'm going to change my yk to tk, so that's going to be equivalent to tk, right, minus 273 equal to x, which is theta c. So my x is theta c. You can see that carefully. And from here, we're taking the 273 outside. We have to take 273 outside, and of course, you get tk to be equal to, right? That will be theta c plus, of course, 273 proved. So there we go. So it's done. That's what we're looking for, and you can say it in the case, and that answers the question.